Hey, this is Jake from BIM Template. So in this video, I kind of wanted to try and start a developer blog or a developer vlog sort of video style. It's not going to be super structured. It's going to be kind of loose and we're just kind of going over what it is that we're working on from the day to day, while also kind of discussing some of the more technical aspects that we run into and how we overcome that. So it's not gonna be one of those day in the life videos, certainly not. But we kind of wanted to just put out there kind of our workflow, what we kind of do, and what we're just working on in the day to day. So one of the things I wanted to discuss is our detail item collection that we're currently working on. So the detail item collection is basically we're reskinning a lot of the Autodesk details instead of just starting from scratch, because we can do that and it's not going to be too difficult to do that sort of thing. The issue comes in with the parameters that you want to include, along with some of the different workflows and setups that you want to try and apply. So when we approached this, we decided that we wanted to, one, let the users have a universal control of the outlines, the section cuts, and try and have like a low line weight for anything that's not section cut, and let the users be able to control the line weights at all sides so that they can kind of set the details up as they need. Along with any of these like linear based families, we want them to be able to control them at the linear length, along with being able to apply like chamfers and line weights and all that sort of stuff. And so all of that kind of starts off by us importing all of the details that Revit has. And so as you can see, there's a lot of details that Revit has already made. There's like about 600, I believe, details. So there's a lot of them to go through. And one of the biggest problems that we first run into is how are we going to be naming the details in the collection? What's the naming standard that we run into? And so Revit already organizes details based on the CSI master format divisions. And so what we kind of did is they didn't have this naming standard applied to the families when they were imported. And what we did is we created a dynamo script that allowed us to be able to basically pull the information that is applied to the folder structure that each of these details were contained in. And then what we did is we then applied those naming standards into each of these. So that way we were able to easily organize all of these, because having all of these organized based on just the naming standard itself, just being like dock bumper and having that organized up here versus having that down here. So it just made it a little bit easier to separate it. And since we're in like 2024 and above, then you are easily able to search that. So that does just help. So if you want to be able to search through divisions and that, it just makes it a little bit easier. So the second thing, once we had that set up, the second thing that we wanted to address is then setting up the naming standards for the parameters and what is the workflow for like tagging and everything like that. And so a lot of that came down to us kind of implementing these parameters inside of graphics. So we'd have a bottom line weight, side one line weight, side two line weight, and a top line weight. So we kind of going like top, side one, bottom, side two. So we kind of just have that structure set up throughout a lot of these families. So this is an older file. I just wanted to kind of show how it's developed, but we'll show you kind of how that's set up in a later version, the one we're currently working on. As well as we're kind of setting up the dimension, side angle, standards inside of here. And so if we, and you can see a lot of those parameters inside of here. So these numbers are controlled inside of yes, no parameters that are assigned to each of the line weights in the other. And so a lot of those are just locked down, and then we just kind of have everything the users be able to control up here. And so that's like been the philosophy, is anything that is formula driven kind of goes into the other category, and then everything else kind of lies up in here, above here. We try to not keep anything close to the other. So you just can just collapse that, and that's really all that's needed. So going into some of the families, we have run into many a times where the families kind of just have like odd naming standards and or mismatched graphic standards, or they just have like various different line weights that don't really align. And that's been it's been a big problem, especially if we want to keep things consistent. So one of the things that you may notice, I don't know if we did it in this one already. So you can see this. So one of the main problems that we have with plywood families is that the graphics, the filled region, is a drafting material, and so it's always going to just go, do that. And then if you have anything that's angled, then it's just going to be cut like that. And we definitely don't like that as a workflow. I certainly like to have the material aligned. We don't do that for everything. So in our more current project that we have open here, so we definitely don't do that for everything. For say like these CMU bricks that we have set up, if we were to rotate them, you can see that the hatching still follows like the typical pattern, so it doesn't rotate with the object. But we have changed things like say this one, where's the plywood, and if we rotate it, you can see that the plywood still aligns with the long edge of the detail. And kind of the same thing with this one. We kind of have set these up to align with the materials instead of, so we basically opted for a material, what's it called, a model based filled region instead of a drafting based filled region. And that's kind of like how we have things set up. We'll still have stuff like, oh, this is like gypsum, or we have like CMU, not CMU. We'll have concrete, stuff like that, and that'll all remain drafting. But some of these more selective materials will automatically align and be a modeling material instead of a typical drafting material. And so that definitely allows us a little bit more flexibility to have more consistent graphics, instead of having things where if we had this and this was rotated, the pattern would still continue left to right. And even though this is the long edge and this is particle board, so basically the way particle board is, structured is it's kind of just compressed material along the same grained path. And so we wanted to make sure that it was graphically represented and kind of aligned with what the material is kind of set up as. I know plywood is a little bit different, and kind of works similar to this, but we wanted to have consistent standard material graphics, and then anything that was not really standard or things that we could find that was kind of uniformly accepted, we've just applied our own material and kind of and working that way. So that's like kind of the other obstacle that we run into. The other thing that we kind of run into is when we're working on object style. So we also have to work on making sure that all of the object style subcategories inside of here remain consistent. So one of the things we don't like to do when we set up family collections is we don't like to have multiple different categories inside of the collection, especially if we sometimes use shared materials or shared families. We don't like to have generic models and then also have casework families be the main host family and have generic models, because then users are having to then remember that they have to go down here to modify like a cabinet leaf or a cabinet hardware in here instead of having it inside of the casework family category itself. So instead we like to opt to have all of the objects delineated based on subcategories that we create and assign to each of those families. And so it's a little bit different inside of detail item families, because detail item families, we don't really need them. They're their own like family type for one, and two, a lot of the graphics that we want to control is just like line weights specifically. And a lot of the details, they're not like specific 3D objects. They're not 3D objects at all. They're just 2D line weights. So one of the things we set up is we just made a consistent line weights for each of these. So this is just a rough setup right now. This isn't going to be the final standard that we have, and the standard number. We kind of just like did this rough setup when we were trying to override a lot of the graphic settings for a lot of the families. So what we did is we just created this little section. We kind of created something that's a little bit more consistent. As you can see, sometimes we have an underscore, sometimes we don't. That's just an error on our part. So we should be able to consolidate those when we're combining those. And so we try to make sure that we have this consistent workflow set up for each of these. And if you're not developing families inside of a project environment like we have here, and you're doing each individual file, you're really missing out on a lot of streamlined workflows, because if you develop inside of a project environment, it makes it so much easier to apply a lot of these standards en masse to the families themselves. Because if you don't have because inside of here, if we already have this, if I were to go and rename this, this renames that object style inside of all families inside each of the family itself. And you can't do that if you're doing individual files. You're just having to remember that you named it that way. And so the way we like to do it is, if we do need to have families that live outside of the project environment, eventually, like they need to be their own separate contained family file, then we will, once everything is developed, then export them into their own contained file. And so that's the other workflow that we've kind of been working on, is line weights and getting those consistent, and make sure the user can modify those. So, and that's one of the other reasons why we have these settings for these line weights for each of the sides, because we have them basically set up as, so let's open the family. So we just have a bunch of different line weights that are set up, and each of them have a graphic override visibility setup assigned to them. And all those are controlled through the other category through different parameters. So you can probably see we need to update this parameter for one. So we try to update the formulas to have them be so that whenever the user sets this to, say, 0, that we at least still show something. Actually, so this one is actually correct, so this one's fine. But it's once we get past 3, so if we were to go here, go past 3, go 4, then the formula breaks, then we go back to 1. And so we want to actually change this formula. So that's actually going to be, so it's going to be greater than 2. Nope, not 12, greater than 2, because that way, if we assign a line that is greater than 3, or greater than 2, or greater than 3, then we have the consistent line weight. So we have, it's 3, 2, 1, and then 0. Then we have the baseline. So basically all the baseline, basically all the families have their own object style set up, and we kind of have a 1 being the baseline. We have 3 at the baseline because we don't want to have any edges that are invisible, because realistically there isn't any. I don't know if you guys disagree with that, if maybe you want to have something that has an invisible line if we turn it all off. But basically all the families are currently set up to have at least all edges to be invisible, aside from select cases. And then we have the second layer of line weights is 3, second layer of line, additional layer is 5, the additional layer is 7. And we have that set up that way so that when users take our families, when they are inside of the project environment, not here, they can just, if they want to change the line weights themselves, they already know that all the families have the same exact line weight object styles assigned. And if they wanted to go in and change those, they can simply go into the object styles themselves, and then they can just change those line weights. So instead of, let's say 3, they can change it to something that's a little ridiculous. They can change it to something that's 9. And so if we were to apply that, it would then take a minute to apply. And as you can see, now all the line weights have been updated. And so it does look a little goofy because of that. But if we have them set up that way, it allows the users to be able to control line weights as they see fit, instead of us dictating how line weights should be. Now, we still dictate that, but this still allows the users the flexibility to change that if they decide later to do that. So what we want to do is change the line weights here. So one of the other things that we are working on is a lot of the families, and this was something that was brought up on a post that we made, somebody commented on it on our page, is we have a lot of these families have 3 different views. They have a section view, they have a side view, and then they have a top view. That's just what Revit has default made before. For all the families. I'm in practice myself. I have not always used that when it came to drawing details, but that's not for us to be deciding on what the user should and should not be doing. So what we've gone and done for these families is we just decided to keep a lot of these details as a section, a side, and a top. Now, one could argue that you could have, instead of having 2 different sides, since these are for the most part, the same exact kind of detail. This is like the line based hosted on the top here, and things stretch this way. And it's the same thing on here. This family is set up that same way too. So you could technically in some way combine these two families and then just be able to swap them out using type family, using the parameters to swap them out and using the family catalogs to do that. I don't think that's necessarily the best form of action when you are setting that up. I like to have them set up as different view types because there's a couple reasons. One, because the families are not always hosted the same. So sometimes the views will have like a center hosting, sometimes they'll have like a top hosting or a bottom hosting, depending on the way that it's oriented, the detail. And so I don't want to dictate how it should be done, as well as we have a lot of these different line weights that also are set up in here. And so having these parameters to be toggled on and off and all these different formulas, it just kind of makes the family so much heavier, and it's already a little bit heavy when you're trying to modify them inside of the family environment. So we try and just like negate that entirely, and we just leave that as is. If you wanted to check out our LinkedIn post about it, then you can see a lot more of our reasons. But we just don't want to be telling the user how to do it. It just like the workflow is a little bit simpler and makes it a little bit more clear out of the box. And if users don't want to use a top view, then they don't have to use a top view. If they don't want to use a side view, they don't have to. And so we just let them decide. So that's the other thing that we do to set up these families. So one of the other challenges is how do we annotate detail item families? So there's a couple of different ways in Revit that you would detail like a construction detail. And obviously you'd have a text note, which is like the most traditional, just like bare bones, very simple. You just like, you draw the detail. You don't even have to use detail items. You can just do a text note, and then there you go. You can just draw a line, and just do, that is a very big line. And just do wall, And we can do that. We can add a leader and you say, all right, there's a wall. Or we can add a little bit more detail. We can draw a layer of gypsum. We can do a section on top of that. Or we can do we can make another filled region so that it's a little bit more graphically clear and all that. So you can do that. That's like the first option. So that's why Revit developed the detail item collection, so that you can just like kind of have these families that already are set details that users aren't going to be like manually dimensioning. And these are all standard dimensions already set up as families. So the method that we decided to go forward is, so you can also keynote detail items. So when you are setting up families, I'm not going to open do the edit type because it takes a while, because there's a lot of families loaded into the project file. So each family has a keynote typically applied to it. Not all of them have that. And these are all standard out of the box Revit notes that they have developed in their own keynote file. And so we're going to have our own custom file that's going to be set up, and we'll have our own workflow and explanation on how to modify that and integrate that into your existing keynote file if you want to use that or change them. And we'll be developing a Dynamo script that's going to be automating and changing that sort of stuff. So Revit already has that stuff detailed. And so when you have that loaded into the file and you go in and then you try and tag it, you try and keynote tag it, do keynote tag, and obviously the keynote will be tagging based on whatever the standard is. We currently haven't finished doing the development of the keynote tag itself. We have some rough diagrams of it, but we haven't finalized it. But the main goal here is that we're going to allow the users to be able to do a keynote, and then if they want it, and then when they're actually developing drawings, they can then have the keynote schedule along the sheet edge, and then the keynote schedule will have that information along what the detail information is assigned to there. Or the users will be able to have the keynote tag where it's going to be text, so that then they can, whatever information is in the keynote file will show up as text here. And so we'll have variable length ones for them to be able to assign. But one of the other things that we decided to implement is allow users to be able to have a little bit more granular control. Instead of having to be tied to a keynote schedule if they don't want to, our keynote file, they can manually assign information. So inside of each of these families, we have three different parameters for annotation. So first off, we have the body text. And so what that's going to be is this is a type-based parameter. And so this will live inside of each individual type. So we can have that be 7/8 inch furring hat channel. And that'll live inside of this existing family type. And so when we can set up different prefixes and suffixes if we want, and so that will automatically be set up inside of there. But we want to have that set up so that if we instead want to just do, say, it's a furring hat channel, and then we can apply that and we can load that. Say we'll just load that into here. Okay, over at existing, so that when we tag that, it'll show up as a actual file. All right, and this way, so we have it. So now that we have that filled in, we can then now if we wanted to say, instead of 7/8 inch chat channel, we can then do a prefix. We can say 1 7/8. Oop. We then say we can have this be an asterisk, and you can have that keyed over here so that it'll have an asterisk on top of there, or you can have a suffix, C contract or C structural. So that way we have this a little bit more rigid naming scheme, tagging scheme. So it allows us to be able to use inside of some existing family type notes that are inside of there, and then we can add some instance-based context inside of there. So we're able to allow users to be able to use keynotes. We want the users to be able to use this existing tagging system if they want to, and if they don't even want to do that, they can even remove the existing body text so that they can use something else instead. So we're going to be setting that up so it's just going to be like, it'll just say like the prefix or suffix, so they can get rid of the body text if they really want to. So we're going to make this as flexible as possible, and we're going to try and populate a lot of this information inside of the families themselves so that the users can just work on it from there. Or if you want to make it better to leave it empty, for the prefix and suffixes, we're open to that. But we'd like to hear some feedback on this tagging system specifically. And I guess so lastly, so we're still working through a lot of the families right now. So currently we're going through the seven division right now. There's a lot of details inside of Revit that we're still working on. So right now, these are all the ones that we're currently actively working on inside of this view. And each one of the families down below that are still ones that have yet to be touched or adjusted, aside from a couple that we've already modified on our own. But each of those are separated into a different category view. This isn't the final organization or layout. This is just us to roughly set things up and apply information without having to have everything rigorously organized and set up already. And so a lot of the things like this one, we have all of our steel beams and all of the ANSI stuff and all the standard stuff that we have, but with all the family types, and have everything set up. So we have different line weights assigned, as you can see, and allow the users to be able to have that flexibility for each of those families. You can do something like that. Lastly, one of the things that we've done to speed up the process of developing families has a lot to do with the dynamo script that we have set up inside of here. And so one of the things we wanted to kind of go over and show you. All right, so one of the things that we were working on when developing these is there is a lot of information that is omitted that isn't set up. First and foremost, when you're opening up a family straight from Autodesk, you see a lot of these standard line weights, a lot of these dimensions are set up, but none of it's visible. So a lot of that has to do with you go down to view, visibility graphics, go into annotations, and here's the other thing, not all this is consistent. Sometimes it's just this is unchecked. A lot of the time this is checked, but then these are unchecked. So it's really inconsistent which family it is. It definitely shows that there's a lot of people that were setting these up and not just a single person. But when you go in and do that, you can see there's a lot of these dimensions and parameters that are set up, but a lot of them aren't clear or apparent what they are specifically. So we have one that's diameter, which is, very clear. Actually, you know what? Let's go back into here, and open up one of the other families. So let's go into the anchor bolts. Here we go. These are better. These ones are quite difficult to to work with and get these set up. So these took a lot of effort. So if we go into here and close that out, and then we go into view, visibility graphics, annotations, show graphics. As you can see, just that step alone and doing that across 600 families, that's a lot of effort. It's a lot of work. So after doing that for a little while, maybe about 20 families, we had to stop and develop a script just to do that. So you can see we have a HDiff, we have a head height, we have these F4s and F3s. You can see it had something to do with the graphics for the bolt head itself. And the washer height and everything, diameter, and the HDiff. So we have all these that are like semi-clear, but if we go into here, a lot of this information still isn't really clear. Now, when you're going and modifying the family, if you go into like the preview, inside the project environment, the dimensions will show up what each of these are controlling. But we like to have this information as abundantly clear as possible for the most part, unless it's correlating with a very specific industry standard schedule table, like specifically the American Institute of Structural the unless it has to do with the ANSI stuff, unless it has to do with the ANSI stuff. So like we do with the steel beams in here. So if we go into here, we can see that we got AISC. So that's what I mean. So if we have something like the AISC, there's a lot of different standard parameters that correlate with tables. So we don't typically try and rename things unless it's like very clear. So we have like TF and D and TW and BF, and a lot of those correlate with those standard tables that you see in the manuals. So we kind of leave that. All we did is we just added our prefix for this collection on there, and we do that for all the parameters. We have our own specific prefix assigned for each of the parameters, and that's just to make it very clear that these are the families that are part of the R collection and they're not part of somebody else's. And that makes it a little bit easier, especially when people tend to import families that aren't associated with our collection and they have different parameters, or they have parameters that are named similarly, such as width and height and all that. So instead we have our stuff set up so that users don't confuse our things with theirs, to make it very clear. Especially when it comes to them trying to modify graphics and they're not understanding that it's not adjusting. It's adjusting for one family, but it's not adjusting for the other. And so that's how we try and make things a little bit more clear. So you can see there's a lot of different parameters set up in here. What we've done, going back to the bolt, is a lot of this stuff was we cleared it up and we've made it so it's a lot more clear how to adjust this information so that users are not confused in the future. So we go to here, bolt fastenings. We go into here, we've already cleaned things up and we've added a lot of graphic standards to make things a little bit more uniform. So you can see we've changed a lot of the namings, and we update formulas so that they correlate with the information that is found inside of the inside of the heads here. The head and the bolt views. So a lot of the time, a lot of the families, they'll have parameters that are driving graphic visibility inside of just stuff that's visible in this view, but they won't have information from the families that are visible in other views. So here, like they'll have the diameter, but they won't have like length parameters. They won't have like the nut head height inside of here, but we've adjusted that. So all the information is inside of each view. Now, it doesn't necessarily matter to have like something like, say we have like the nut, the bolt diameter, height, or the head chamfer on the other view, but we have it on this view. But we like to make those information consistent, specifically saying like we have like the bolt diameter, whereas like in this view you don't need to have the bolt diameter inside of here because it's not visible in view, but it's good because it's still a part of the same family type. It's part of the same information. So we want to have all of that be consistent. So we've gone through and added everything that is needed inside of all three of these views are all visible in all three of these different views. So just so everything is consistent. Anything that's just like a minor graphic thing, then we don't include that. But we try and make everything as consistent as possible so that it's its own uniform part and it's all consistent across all different types of views. And users don't have to modify that if they don't want to, but we try and make that as consistent and reliable as possible. And that's the main key here, is making sure everything in the collection is consistent. And that's a lot of what was left out of the original details, is that there's a lot of consistency that wasn't there. And we're making things much more uniform and consistent. So going back to our families that we modified to make things more consistent. So first we had the views, we had to change the visibility graphics and make sure that those are turned on so that we can modify that stuff. The next thing that we had to do is we also had to create the different object styles. So not all object styles, even though we modified them in the project environment before we open them in the family environment. And once we do that, like if we were to name that, then it would come in here and it would actually show it correctly. But sometimes they would only have one or two different categories inside of there. And we need to have all of them for the various different views that we, for all the different lineways that we want to set up. So what we would need to do is then manually have to create each and every one of those inside of the families. And that takes a lot of time. It's opening, creating, deleting, or renaming. That just a lot of work we didn't really need. And then the other thing is we have all these different formulas and parameters that we wanted to import. So we have some standard parameters that we wanted to import. And then we have these different shared parameters that we wanted to set up that were linked to formulas inside of these. So these ones are not these ones inside of the other. These are just family parameters, and these ones are shared parameters. Simply, we like to use shared parameters as much as possible, except for when it doesn't really make sense or isn't needed. So for stuff that's just formula driven that users aren't going to be modifying, we sometimes opt for or when users don't actually need to reference that inside of a schedule, we opt for a family parameter because it doesn't really matter on the users or our end. But for other things like this, like we want to see the bolt diameter, the washer, the head flat, if they were to schedule this information, these are all family parameters that are shared parameters that users will be able to modify and import into schedules. But replacing all of the existing formulas or the existing parameters and then replacing those with our specific family shared parameter naming standards is a challenge, because either we have to go through and manually do that for each and every one of them, as well as also import the ones that we need to import. And doing that across 600 different families is a lot of work. So it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then creating these 14, 15, 16, 17, 18, 19. And then here's your standard 20 and 21. And all this information is just so much work to do for each and every family. So this could take us an entire half a year just to get this done if we did this all manually. And especially if we decide to change things later on, it would take forever. So one of the things that we did to speed up the process is we created a dynamo script. And so I'm going to show you that in 1 second. So let's go into Dynamo. We're going to create that. So we created a script. All right, so here's the script in its entirety. I don't know what's going on here. That's a little weird why it's doing that. So here's the script in its entirety. It's pretty complex. First, we're adjusting the visibility graphics and turning those on and off to make that, just automate that stuff so we don't have to do that manually every single time. And then what we're doing is this section of the script is creating the object styles inside of the family. And then what we're doing is we're checking to make sure what object styles we currently have in the file. And then we're creating these ones to filter and then setting those up. And then we're applying the line patterns that we have set up, and we're applying the line weights inside of there. And once we have that, that's all then created. And once this is the first step, and then this is the second step. And once those are completed, we have a pass-through parameter to kind of wait before any other processes are completed. And so the next step is then importing parameters that we have set up. And so the way that we import parameters is we basically use an Excel file. Now, so for our purposes, we don't use Microsoft Excel. We use a third party. We use the open source one, and we use it. So we use a CSV file. So Revit has to treat that. Dynamo has to treat that a little bit different in importing that information. And essentially all that is basically we create this Excel file that has all of the information. We have a checkbox whether this is going to be an import. So basically we have the Dynamo set up so that it'll check if we have an X here. That means it'll just automatically be imported no matter what. We just have told it import this no matter what. So we want to have these families, these parameters loaded every single time. And then we have our existing parameters. So basically the script will check whether or not these names for parameters exist inside of the file. And if it exists, then we want to replace it with this parameter itself. So it'll load the shared parameter that we have set up, and then we assign whether it's an instance or a type-based parameter. We then assign what the group type is inside of the file itself, and then we assign the shared parameter file grouping itself. And then if it's a family type, then we do a family parameter. We specify the spec type, we specify the value, and we specify if it's a formula. And so this schedule will go and take this information and then apply this inside of the file. And so this does this automatically. So this takes like maybe a 10-minute setup process, 5 to 10 minute setup process for each and every family, and automates it to just about 30 seconds at most, just to process it. And so a lot of that comes down to us using a couple of different packages, but mostly relying on the Orchid core package and the Orchid family package. If you haven't used that, I would highly recommend using that one. But we are importing the Excel file into here. We're using the crumple delimited node here. And that was just because we had some inconsistencies in what the Orchid one was requiring us to do. And so this one just made it a little bit more clear and easy. And then basically here we go. We're checking whether the existing parameters exist and getting the row index for all of that. And we have a lot of different stuff that we're not going to specify here, but basically we're checking whether the family, the parameters exist, and then we're replacing them, and we're doing all this import and getting all the data to then assign the the shared parameters. And here we have like a specific like group typing. So we originally had the script set up in 2023, but one of the limitations of 23 and 24 is when Revit changed their parameter naming standards for the group type. And so there wasn't an ability to be able to specify other very well. Prior to that, they were able to, I believe. But in 23, there was like something broke, and users aren't able to specify the other category anymore, or there wasn't any packages that allowed you to be able to do that, such as the Orchid. Orchid has been the one that's been most helpful. And so we moved up to 24, and there's a specific out-of-the-box node now that allows us to specify the other group. And so we're having to filter that information to be able to then delineate which parameters we're importing to the other group, because previously what we had to do is we specified these as a different group type, and then we then use a different extension to then move those to the correct other category. And so with this one now in 24, we're able to bypass that and just automatically assign it, which is like, that saved us so much more time too. And so once we have that, we create the shared parameter and assign it. And then what we're doing is, instead of just replacing the shared parameter that's inside of the family here, what we'll do is we actually will create the shared parameter, and then through formulas link the parameter to itself. So what we'll have is we'll have one that's diagonal. We'll have one that's a bolt diameter. It'll just be a diameter, and then it'll go through and import this parameter, and then it'll just assign the original bolt diameter to the DI bolt diameter. And the reason we did that, instead of just automating, replacing that, is so that we could audit each and every file. Because Revit is inconsistent in each of the families, it's only slightly consistent on each of the families that are created. We wanted to be able to audit every single one of them, to be able to check and make sure each family is automatically being associated, because we didn't want to just do it and have Dynamo run for like an hour and complete the script and then find everything is just completely screwed up, because there's a lot of dimensions that are in here that didn't make sense. If you remember the other bolt, it like had some different ways that it was doing it. It was splitting faces instead of having one dimension for the flat. It was saying like here F3 here and then F3 here, instead of just having one diagonal head flat here. And so we wanted to be able to audit all this information and be able to adjust it and swap things out as needed. And it's been quite helpful on that front to be able to swap that information out. And so going back, we have that information. Now that we have those linked up, we now are able to take those new shared parameters, and a lot of these files will automatically have dimensions associated, and they'll have a parameter associated. So what we'll do is, now that we have the new shared parameters being associated to the existing parameter that's in the file, we will then have Dynamo go in, check each of the dimensions that have a formula assigned, and then what we're going to do is then replace each of those that have an associated dimension with the new formula. So we've already gone through and we don't have to replace all the dimensions now, and all we have to do is just check and make sure the dimensions are correct, check and make sure the parameters are correct. And once that's done, then we go through and we have whatever formulas inside of the Excel file that we want to apply to make things a little bit more automated, so that each of the family types are consistent with the dimensions that we want. And we found that it was a little bit easier in some packages. We haven't checked in this version of 24, but in 23, the ORCID package wasn't doing well at populating assigned values to all of the family types. And it only did that for some of them, or just the one that you had open at the time. So that's something that we'll look into. But as of right now, it hasn't been a big deal, because we still sometimes have to make some adjustments, go into the project environment, and then use our IDA BIM link to export a schedule and then reassign the parameter values when we're trying to replace a family. Because sometimes it's a little bit easier to use an existing family that we have set up, instead of then recreating it inside of the existing family itself. So we'll have like the linear length ones that will be linear length ones, like the plywood, or we'll have ones like, computer's running a little slow, Dynamo's a little heavy. So instead of then just recreating, say, this family using the existing setup that they have, we will just use this one that we already have everything set up, everything is all correct, and all we're going to do is then just go open it, rename the file, replace the filled region with the correct pattern type, reload it into the file, and then use BIM link to export the schedule information for each of the parameter data, and then just update and create the new family names and create and assign the correct parameter values. So it makes it a little bit easier to update the information. And going back into then Dynamo, we can then, once that information is all set up, we have the dimensional strings assigned, and we apply the correct labels. And then and that's really it. That's it for the Dynamo script. It took a little while to develop, but that made things move so much more smooth, and we had to do so much less work on top of that. moving up to 2024 was the choice to do that. And so we don't want to make any changes to this, and we want to go back into here, and let's go into, and we'll just show you like some of the process for updating one of these families. So we can go into the installation flashing. Let's go into here, and let's open up this one. So if we go into here, you can see it's very typical what we have set up. But if we were to go into our dynamo, here we go. We're to open up. Oh, oops, that's not working. So let's close that and open that back up. All right, here we go. And so here's our family. We used to have them in 2023. And so now if we were to click run, it'll start running, start thinking and analyzing the file and replacing things. All right, and as you can see, now we have the different dimensions. We have the shape parameters inserted, and then we have them associated, and the labels for the dimensions have been replaced. So you can see we have these associated, and now that we have that, since we don't have these applied to the wrong label, we can just go and confirm that those are correct. We can just delete that, and we can do the same thing here. See, we don't want those there. We actually want them here, and we can delete that. And we can delete that. One other thing we didn't mention with the Dynamo script is we have the ability to reorganize all of the parameters to make sure they are all consistent in the right order. Because sometimes when you import a parameter or add a parameter, it'll just like reorganize it alphabetically. And we don't necessarily want that. And having to manually resort that every single time is a real pain in the butt. And so our Dynamo script will actually resort all of that information, all those parameters to the correct order. And the way that we have that done is basically what we have set up in the Excel file. The order that we have this set up is how Dynamo should reference to organize all of the parameters. It makes things so much easier, and we don't have to resort everything in category. It just makes sure everything is sorted inside of the right group type. It makes things so much easier. As you can see, we have everything already set up. The main thing that we would do is we'd go through and adjust these line weights. We'd make sure that we have stuff like the detail item view regions are set up to the correct line weight. So we want to have those set up to 1. And then we would then renaming these, and we would assign a visibility graphic to the different line weights and have those set up. And that's basically what we would be doing. We'd load that back into the project, and then that's it. That's how we have everything set up. So that is a brief overview, very extensive, but a brief overview of what we've been working on and how we have been developing our workflows to adapt to this new collection. Let us know if you have any questions or if you have any insights. If you have any improvements, that would be real great.